building up a basic demo with Three.js, and we want to create this final product, so we have to create these three shapes. So a typical 3D scene, and again even the simplest one, contains standard items like shapes located in a coordinate system, a camera to actually see them, lights and materials to make it look better, animations to make it look alive, etc. Three.js, as with many other 3D library, provides built-in helper functions to help you implement common 3D functionality more quickly. In this article, we will take you through the real basics of using Three, including setting up a development environment, structuring the necessary HTML, the fundamental objects of Three, and how to build up a basic demo. So we have that. Now, note, we chose Three because it is one of the most popular WebGL libraries and it is easy to get started with. We are not trying to say it is better than any other WebGL library available, and you should feel free to try another library such as Copper, Licht, GLGE, and Play Canvas. So environment setup to start developing with Three.js. You don't need much. You should make sure you are using the modern browser with good WebGL support, such as the latest Firefox or Chrome. Create a directory to store your experiments in, so let's do that. We're gonna go to my folder programming.js, and I'm gonna have a folder named Three, so I'm just gonna name it like that, Three. And what is it here? So I'm just gonna right click, open in terminal, and then just type in code space that, so I can open it with Visual Studio Code. So let's close, or let's move this one to the left. Okay, so we have that. Let's close this terminal, let's close this window. Okay, so save a copy of the latest minimize Three.js library inside your directory. So you can click here and you can copy and pretty much inside some JavaScript files, so you can do that. Or here I'm gonna show you a link that is this is the one. This is the GitHub where we have all the code. So I'm just gonna go in the JavaScript in the JS, and this is pretty much the same, the latest minimize Three.js library. So this whole thing is in here. So let's just click it, and okay, it's gonna take a while, and you need to name it Three.main.js. And pretty much we can just raw download it like that. So I think I downloaded to my download, so okay, I have it here. Let's just cut it, and I'm gonna go into my programming.js. I'm gonna go in Three, and I'm gonna paste it. So I have it already here, and it's named Three.main.js. Or you can just pretty much have you create a file named Three.main.js, and then you would copy this whole code here and you would paste it there. So you can do that. And this GitHub link is inside of this website. So let me see, if we go all the way down, if we go all the way down, you are gonna see it in here. Check it out on GitHub. You click here, you have all this code, and you just go into the Three.js, and you go into the JavaScript. So we have that up to this point. Okay, so open the Three.js documentation in a separate tab. It is useful for reference. So we have that, and okay, so now HTML structure. Here is the HTML structure we will use. So let's copy just the HTML, since it's just HTML, and we're just gonna name it index. So it's gonna be index.html like that, and we're gonna paste it here. Okay, so we have just the this is classic HTML. So we have the doc type HTML, then we have the HTML language English GB, then we have the head, and we have the head here, and we have the body. Okay, so inside of the head we have the meta, and we have the char set to UTF-8. The title, so the title is MDN Games Three.js Demo. So we can just right click and just open with live server. So we're not gonna have anything, but you can just check out the title, MD Games, Three.js demo. So we have that up to this point. And below the title we have the style element from here, from line 6 to line 15. And inside of the style element we have the body and we have the canvas. So the body has a margin of 0 and a padding of 0, and also a canvas with a width of 100% and a height of 100%. So that is the style element, and this is inside of the head element. Now we're gonna go inside of the body. Inside of the body we have the source, that is the three.main.js, and we already have it here. And remember, I just downloaded that I downloaded for here the three.main.js. So if you want, you can just pretty much copy this whole code and just save it into a JavaScript file and name it three.main.js. Okay, that is the first script. Then we close it. Then we're gonna have a second script, and let me see. Okay, what we are gonna do right now is we could pretty much copy all our JavaScript inside of this HTML file, but what we are gonna do is we're gonna cut it. So I'm gonna cut this whole thing like that, and I'm gonna create a new file, and I'm gonna name it main.js like that, and I'm gonna paste it here where I just copy it or where I just cut it. Okay, so in the index.html file inside of the second script, what we are gonna do is we're gonna insert a source and we're gonna set it to main.js. So we have that, and yeah, that's fine. So now all our JavaScript we can start coding inside of a JavaScript file, not inside of the HTML file. So we have that comment, all of our JavaScript goes in here. So up to this point, let me see if something has changed. So let's move this one here. I have to, what else? Okay, so building more shapes. Let's close this one too. Okay, so there's nothing here, and let me see. Okay, so up to this point we only have two constant declarations, name width and height, and the width is being set to window that inner width, and the height is being set to window that inner height. So we have that up to this point. Now it contains some basic information like the document title, and they're talking about the HTML file, and some CSS to set the width and the height of the canvas element. The Three.js will insert on the page to 100% to fill the entire available viewport space. The first script element includes the Three.js library in the page, and we will write our example code inside the second. Okay, so they're talking about, this is the first, let me see, this is an index, this is the first script. So they said we will type our code in the second, but we're not gonna do that. We're gonna type our JavaScript in the main.javascript file that I just created. Okay, so there are two helpers variables already included, which store the window's width and height. So we have those two helpers. Before reading further, copy this code to a new text file and save it in your working directory as index.html. And that's exactly what we already did. So we save it, and let's close this one too. Okay, now rendered. Rendered is a tool which displays scenes right in your browser. There are a few different renders. WebGL is the default, and others you can use are Canvas, SVG, CSS, and the DOM. They differ in how everything is rendered, so the WebGL implementation will implement differently than the CSS one. Despite the variety of ways they achieve the goal, the experience will look the same for the user. Thanks to this approach, a fallback can be used if a desired technology is not supported by the browser. So we have that, and here we have this constant declaration and render, and we are setting it to the new.3.webgl that render anti-alias, and we are setting it to true. Then we have the render that sets size, width, height, and we have the render set color 1, document that body, append child, and render that element. So we are creating a new WebGL rendered, setting its size to fit the whole available space on the screen, and appending the done structure to the page. You might have noticed the anti-alias parameter in the first line. This renders the edge of shapes more smoothly. The set clear color method sets our background to a light gray color instead of the default black. Add this code into our second script element just below the JavaScript comment. So we're gonna start working with this. And okay, so we're gonna go into the main, and we're gonna have this constant declaration. So we're gonna have this constant declaration in render. Okay, it's gonna be rendered like that, and we are gonna set it to the keyword new, and we're gonna set it to this time. It's gonna be 3 dot, and we're gonna have the WebGL render. So it's gonna be, let me see, WebGL. Okay, WebGL. Okay, so WebGL render like that. WebGL render, and then we're gonna open parentheses, and inside of the parentheses we're gonna open curly braces, and let's end this whole statement with a semicolon. But let's go back to the curly braces, and we are gonna have in the anti-alias. Okay, anti-alias, and we're gonna set it to true. So we're gonna set it to this boolean. So we have that to this, up to this point nothing has changed. Let me see, we have this constant declaration name render. Okay, let me see, has to be renderer. Okay, that's fine. Now just check out the spelling. It has to be WebGL okay, render aquí, here, renderer. Okay, so we have that. Then anti-alias set to true. Okay, that's fine. Now we're gonna use this renderer, and we're gonna use the method, and the method that we're gonna be using is the set size. So it's gonna be set, the method that we're gonna be using is gonna be set, let me see, no, not that one. It's gonna be the set size. Okay, and we're gonna pass in these two helpers, the width and the height, in uppercase letters. So it's gonna be the width, and it's also gonna be the height. Okay, so let's save it for now, and nothing has changed. That's fine. Okay, so we have the width and the height. That's awesome. Okay, so let's end it up with a semicolon, and now we're gonna use again the same constant declaration renderer, and we're gonna use this method set clear color. So it's gonna be set clear color. We're gonna open parentheses, and this time we're gonna use this hexadecimal number, so 0x, and then we're gonna have 6 these. So, okay, 1 2 3 4 5 6. Okay, and then as a second parameter it's just gonna be the number 1. Okay, so we have that up to this point. So ended up this one with a semicolon, and finally we're gonna have the document dot. So it's gonna be document dot body. Okay, and then that appendix child, and we're gonna pass a renderer that done element. So open parentheses, and it's gonna be renderer that, and it's gonna be dam element. So it's gonna be dam element like this. So let me see if this is right. So document that the body that append child. Okay, or renderer that dam element. Okay, and we're gonna end it up with a semicolon at the end. Okay, so we have that, and it has changed. As you can see, now it's dark, it's pitch black. Okay, let me see document. Okay, we are okay, so yeah, we already read this part, so we have created that. Now we're gonna move into the scene, And if you wanna just check it out real quick, we are creating a new WebGL renderer, setting its size to fit the whole available space on the screen and appending the DOM structure to the page. You might have noticed the NTLS parameter in the first line. This renders the edges of shapes more smoothly. The setClearColor method sets our background to a light gray color instead of the default black one. So we have that. And set clear color. So let me see if I set clear color. And let me see, let me just do a double check if I type everything right. Document that body that append child. Okay, so then this one is okay 0. Let me see if I type in. Okay, that's fine. And then is 1, then the width and the height, then we have the NT alias set to true. Okay, so everything is fine. Okay, yeah, let's keep moving. Now the scene. A scene is the place where everything happens when creating new objects. In the demo, we add them all inside the scene to become visible on the screen. In the Three.js, the scene is represented by the scene object. Let's create it by adding the following line below our previous line. So let's create it by adding the following line below our previous line. So we are gonna go right here, and we're gonna have this constant declaration named scene, and we are gonna set it to this keyword new, and we're gonna use it's gonna be 3 dot, and it's gonna be scene. So the first letter is gonna be written with or typing with capital letters, then parentheses, and then semicolon at the end. So we have this constant declaration named scene, and we are setting it to the keyword new 3.scene. Okay, that's fine. Now later we will be using the add that method to add objects to the scene. Okay, so now we have the camera, we have the render scene, but we still need to add a camera to view our handiwork. Imagine a movie set without any cameras. The following lines put the camera in place in the 3D coordinate system and point it in the direction of our scene so we can finally see something. Okay, so we're gonna use this constant declaration. We're gonna have this constant declaration named camera. Okay, let me see. Okay, and we're gonna set it to the keyword, and it's gonna be 3 dot, and it's gonna be perspective camera. So we're gonna have the, let me see, perspective camera like this. So let me see if I type it right. So perspective camera. Okay, and we're gonna pass some values. So it's gonna be 70 comma, then we're gonna have in the width, and it's gonna be divided by the height. So like that, and let's just separate this one. Okay, so we have the width divided by the height. Okay, so we don't have any shapes up to this point. We don't have the torus, the cube, or what else, the torus, the cube, and a cylinder. Okay, now we're gonna have the camera at that position, that C. So we're gonna use the C coordinate. So we're gonna set it to 50. So we're gonna use this variable declaration in camera that we just created, that position, that Z, and we are gonna set it to 50, and we're gonna end it up with a semicolon. Okay, again, nothing has changed because, well, it has changed, but we cannot see it since we are not adding objects, or we are not adding objects or shapes. So camera position, that Z, and then we're gonna have in this the variable declaration that we just created in line 10, that is scene. So we're gonna have scene, and we're gonna use the method, and the method that we are gonna use is gonna be the add method, and we're gonna pass in the camera. So like that, ended up this statement with a semicolon. We have that up to this point. That's good. Add the lines. Okay, add the above lines to your code below the previously added. There are other types of camera available: cube, orthographic, but the simplest is perspective. To initialize it, we have to set its field of view and aspect ratio. The former is used to set how much is seen, and the latter is important for the objects on the screen to have the right proportions when rendered and not look stretched. Let's explain values we are setting for the code above. Okay, the value we set for the field of view 70 is something we can experiment with. The higher the value, the greater the amount of scene the camera will show. Imagine a normal camera view versus a fisheye effect, which allows a lot more to be seen. The default value is 50. The aspect ratio is set to the current width and height of the window, so it will be dynamically adjusted. We could set a fixed ratio, for example 16 by 9, which is the aspect ratio of a widescreen TV. The default value is 1. The Z position with a value of 50 units is the distance between the camera and the center of the scene on the Z axis. Here we're moving the camera back so the objects in the scene can be viewed. 50 feels about right, it's not too near or too far. And the sizes of the objects allow them to stay on the scene within the given field of view. The X and Y values, if not specified, will default to 0. You should experiment with these values and see how they change what you see and the scene. So right now, again, we only have this whole pitch black, but we are gonna start adding some shapes. The distance values, e.g. the camera Z position, are unitless and can be anything you deem suitable for your scene. Millimeters, meters, feet, or miles is up to you. So now, rendering the scene, everything is ready, but we still cannot see anything. Although we've set up the render, we still need to render everything. Our render function will do this job with a little help from the request animation frame, okay, which causes the scene to be re-rendered constantly on every frame. So we are gonna go below and we are gonna create a function and we are gonna name it render. Okay, so we're gonna have that. We're gonna open curly braces. Let me see. Yeah, that's fine. Render. Okay, so we're gonna call in the request animation frame. So let me see if I have a request animation frame. That's fine. Open parentheses and we're gonna pass in the render. And there are with a semicolon, and now we're gonna use this. We're gonna use the renderer. So it's gonna be renderer, and we're gonna use a method, and the method is just gonna be the render. Okay, and we're gonna pass in two parameters that is gonna be the scene. They're gonna be the scene and the camera, like that. We ended up with a semicolon at the end, and outside of this parenthesis, outside of the curly braces of the function render, we are gonna call in the render function, like that. We are just gonna call it and semicolon at the end. Okay, so yeah, the color has changed. As you can see, we can move this one around, but still we don't have any shapes, any objects. So on every new frame, the render function is invoked, and the renderer renders the scene and the camera. Right after the function declaration, we are invoking it for the first time to start the loop, after which it will be used indefinitely. Again, add this new code below your previous additions. Try saving the file and opening in your browser. You should now see a gray window. So now geometry. Now our scene is properly rendering. We can start adding 3D shapes to speed up development. Three.js provides a bunch of predefined primitives which you can use to create shapes instantly in a single line of code. So there are cubes, spheres, cylinders, and more complicated shapes available. Details like drawing require vertices and faces for a given shape and handled by the three frameworks. So we can focus higher level coding. Let's start by defining the geometry for a cube shape, adding the following just above the render function. Okay, so above the render function. So what that means is we're gonna start typing our code here. So we're gonna have this constant declaration name. Let me see, it's gonna be box geometry, so it's gonna be the box, it's gonna be box geometry, so camel notation, and we are gonna set it to, again, the keyword new, and it's gonna be 3. It's gonna be the method that box geometry, so it's gonna be that box geometry, like that, and we are gonna pass in these values like that, and we're gonna save it, so semicolon at the end. And let me see, nothing has changed yet, so we have this constant declaration name box geometry. We're setting it to the new 3 dot box geometry, and we're gonna pass in 3 values. In this case, we define a simple cube that is 10 by 10 by 10 units, so the geometry itself is not enough though. We also need a material that will be used for our shape. So a material is what covers an object, the colors or textures on its surface. In our case, we will choose a simple blue color to paint our box. There are a number of predefined materials which can be used: basic, foam, Lambert. Let's play with the last layer, with the 2 ladder, but for now the basic one should be enough. So let's move here just below the box geometry, and we're gonna use this constant declaration name basic material. So we're gonna have this const, and we're gonna name it basic material, like that, and we are gonna set it to the new, and it's gonna be 3 dot, and it's gonna be mesh, like that, mesh basic, okay, and it's gonna be mesh basic material, mesh basic material, like that. We're gonna open parentheses, and we're gonna open curly braces inside of the parentheses, and we're gonna have the color, and we're gonna set it to this 0x. Let me see, it's gonna be set to 0x, and then 0095D, and we're gonna end this statement with a semicolon. And let me see, nothing has changed yet. Okay, so we have, let me see, basic material new 3 mesh basic material, we have the color, and we have 0, okay, and it has to be double D. Okay, so I omitted this double D. Okay, add this line below the previously added. Our material is now ready. So what's next? Now we're gonna see the mesh. Okay, so we're gonna, oops, let me see, nothing has changed, but we're gonna add the mesh. To apply the material to a geometry, a mesh is used. So again, to apply the material to a geometry, a mesh is used. This takes on a shape and adds the specified material to every face. So now we're gonna have finally our cube. So we're gonna have this constant declaration named cube, and we are gonna set it to the keyword, and it's gonna be 3 dot, and let me see, and it's gonna be mesh. Okay, and this time we're gonna use these 2 parameters. So we're gonna open parentheses, and we're gonna have in the box geometry as well as the basic material, like that, ended up with a semicolon. Okay, so again, add this line below the one you previously added. So nothing has happened yet. Let me see, we have this constant declaration named cube new 3 dot mesh, and we're passing the box geometry as well as the basic material. Okay, that's fine. Adding the cube to the scene now. We have now created a cube using the geometry and material defined earlier. The last thing to do is place the cube on our scene. Add this line below the previous one. So okay, so it's gonna be just right here. Yeah, we can just go here and just pretty much type it in cube, and we are passing it, we are passing in as the scene, and inside the scene, inside of the parentheses, we're gonna use the scene add, and we're gonna pass in the cube. It's gonna be like this, cube, semicolon at the end. Let me see, so we have the scene, the method, so we're adding, and we are adding the cube. So let me see if this is working. Okay, so we have this square, this is a cube, but we're gonna, is the way it's facing the camera, so now we're gonna modify it. If you save and refresh your web browser, our object will now look like a square because it's facing the camera. The good thing about objects is that we can move them on the scene however we want, for example rotating and scaling as we like. Let's apply a little rotation to the cube so we can see more than one face. Again, adding our code below the previous, so we're gonna have the cube dot rotation dot set, so it's gonna be here cube dot rotation dot set, cube dot rotation dot set, and we're gonna have the 0.4 comma, we're gonna have the 0.2, and finally we're gonna have 0. So let me see, I haven't saved it, but if I save it right now, as you can see, it has moved a little bit. So if I refresh it, okay, it has moved a little bit. So we have that, so we have the cube that rotation that set, and we have the 0.4, we have the 0.2, and we have 0. Okay, that's fine. Congratulations, you created a 3D environment. Okay, that's fine. So it's looking like this, and here is the code that we have created so far. So that's pretty much it, and you can also check it out in the GitHub repository. So yeah, there you have it, the GitHub repository. More shapes and materials, and we're almost done. Now we will add more shapes to the scene and explore other shapes, materials, lighting, and more. Let's move the cube to the left to make a space for some friends, adding the following line just below the previous one. So we're gonna have the cube that position that x. Okay, so we're gonna have the cube that position that x, and we're gonna set it to -25. We're gonna end this statement with a semicolon, and we have moved this cube to the left, as you can see. So we have the cube that position that x, we're setting it to -25. That's fine. Now onto more shapes and materials. What might happen when you add a torus wrap in the foam material? Try adding the following lines just below the line defining the cube. Okay, so we're gonna have this, we're gonna go below, and we're gonna have this constant declaration name torus, and it's gonna be torus geometry, and we're gonna set it to the new 3 torus geometry. Is gonna be the new, and it's gonna be 3, and it's gonna be, okay, it's gonna be, let me see, torus geometry, and we're gonna open parentheses, new 3 that torus geometry, and we're gonna pass in the numbers, the parameters is gonna be 7 1 6 12, 7 1 6, and then it's gonna be 12. So we can put a semicolon at the end and just press save, and okay, nothing has changed up to this point. But let me see, now we're gonna have this constant declaration name foam material. So we have this constant declaration name okay, foam material. Okay, and we're gonna set it to the new, we're gonna set it to the new. Okay, it's gonna be new, and it's gonna be 3 that, and it's gonna be set to mesh. It's gonna be set to mesh, and it's gonna be set to mesh foam material, like that, material. And we're gonna open parentheses, and inside the parentheses we're gonna open curly braces, and we're gonna have the color, and we're gonna set it to 0x95 and 0x double f 9500. Okay, that's fine. We can save it up to this point. Nothing has changed. But now we're gonna finally add the torus. So let's send it out with a semicolon, And now we're gonna add this variable declaration name Taurus, and we're gonna set it to the keyword new, and it's gonna be 3 dot. It's gonna be okay, new 3, and it's gonna be, let me see, it's gonna be mesh. Okay, and remember, after the dot, the first letter has to be initialized in capital letters. So mesh dot, we're gonna open parentheses, we're gonna pass in the torus geometry. It's gonna be the torus geometry. We're gonna put a comma, and then we're gonna have the foam material. So let me see. Okay, we can save it up to this point, semicolon at the end. And we're not gonna see it yet because we are not calling it with the scene. So in order to see it, we have to type in scene.add and then pass in the shape. In this case, the shape is the torus. So we can go here and just type in scene, the method add, and we are passing the torus like this, semicolon at the end, save it, and there you have it. So we have the torus. So okay, we're gonna add animations, but okay, it's looking basic, but let's keep moving. These lines will add a torus geometry. The torus geometry methods parameters defined, and the parameters are radius, tube diameter, radial segment count, and tubular segment count. The foam material should look more glossy than the back simple basic material, though right now our torus will just look black. Okay, as you can see, the torus is looking black here. We can choose more from predefined shapes. Let's play some more and add the following lines below those defining the torus. So now we're gonna have this dodecahedron geometry. Okay, and we need, okay, once we're gonna declare, we're gonna choose the scene.add and then dodecahedron, we're gonna call it. So I don't know if that's how you pronounce it. Okay, so let's go below, and we're gonna have this variable declaration name. Let me try it. It's gonna be dot. Okay, dot cahedron. Okay, dodecahedron geometry like that. We're gonna open parentheses. Oops, no, we are gonna set it to the keyword new. So okay, so dodecahedron geometry. Okay, we are gonna set it to the keyword new, and we're gonna have in 3 dot, and it's gonna be, okay, the first one is gonna be, okay, dodecahedron like that. Let me see, geometry, dodecahedron geometry. Oh, that's a mouthful. Okay, geometry. We're gonna open parentheses. Let me see. Yeah, and we're gonna pass in just the number 7, ended up with a semicolon. And again, nothing has changed because we still need to call it with scene.add and then dodecahedron. Okay, but for now, let's keep moving and let's create this constant declaration name. Okay, Lambert material. So it's gonna be Lambert, and then it's gonna be material. Okay, Lambert material, and we are gonna set it to the keyword new. Okay, and let me see, we're gonna use the keyword new, and then it's gonna be 3 dot. Okay, 3 dot mesh. It's gonna be 3 dot mesh, and it's gonna be Lambert mesh Lambert. So mesh Lambert material like that. We're gonna open parentheses, and we're gonna open curly braces, and we're gonna have in the color column, and then the color is gonna be set to 0x, and we're gonna have EAE, so EAE, and then we're gonna have double F and then 2. Okay, so we can save it, semicolon at the end. Okay, so now we're gonna create a constant declaration name dodecahedron. Okay, or whatever you name it or whatever you pronounce it. So it's gonna be dodecahedron. Okay, dodecahedron, and we're gonna open parentheses. No, we're gonna set it to the keyword new, and it's gonna be 3 dot mesh, like that. 3 dot mesh, and we're gonna pass in the dodecahedron geometry. So dodecahedron geometry, as well as the lumber material. So it's gonna be the lumber material. Okay, so end it up with a semicolon at the end, and let's do something. Let's just call it. So it's gonna be sim that add, and we are gonna call the dodecahedron, semicolon at the end, and let's just see how it looks like. Okay, so it's taking the place of the torus, but now just before the scene that add, what we are gonna do is we're gonna type in the, okay, it's gonna be dodecahedron that position that x, and we are gonna set it to, let me see, it's gonna be set dodecahedron, we're gonna set it to 25. Okay, so we're gonna move it towards the right. Okay, and as you can see, we have that. And if we just put it to negative 25, we're gonna move it to the left, and yeah, it's looking kind of weird, but let's just keep it at 25 and let's keep moving. Okay, so we have 3 shapes up to this point: the cube, the torus, and the, what is the name of this one, dodecahedron. So we have that 1 2 3 4 5 6 7 8 9 10. Okay, 10 lines or sides. Okay, this time we're creating a dodecahedron, a shape containing 12 flat faces. Okay, the parameter dodecahedron geometry defines the size of the object. We're using a lumber material similar to the foam, but should be less glossy. Again, it's black for now. We are moving the object to the right, so it's not in the same position as the torus, as the box or the torus. So we have that. As mentioned above, the new objects currently just look black. To have both the foam and lumber materials properly visible, we need to introduce a source of light. So the lights, there are various types of light sources available in Three.js. The most basic is point light, which works like a flashlight shining a spotlight in a defined direction. Add the following lines below your shape definition. So we are gonna have below this one, and yeah, just before the function render, we're gonna have this constant declaration named light, and we are gonna set it to the keyword new, and then it's gonna be 3, and then we're gonna use this method that is gonna be point light. So let me see, it's gonna be point light. We're gonna open parentheses, and we're gonna pass in this number 0x, and then we're gonna have in 6f. So 1 2 3 4 5 6, semicolon at the end. Okay, so now, and again, nothing is gonna happen because remember, we have to call it with seeing the data light. So we're gonna use this constant declaration named light, and we're gonna use a method inside of that is the position, and the position that set, and we're gonna pass in some values here. Namely, it's gonna be -10, so it's gonna be -10, 15, and then it's gonna be 50, like that, semicolon at the end. And finally, we're gonna have in the scene that add, and finally we're gonna pass in the light. Let me see, what do we have here? And now it's taking some light, it's taking some shape, some color, so it's looking good. So we have 3 shapes: the cube, the torus, and the, yeah, this mouthful. So that is the dodecahedron. Okay, we have that up to this point. We define a white point of light set its position a little away from the center of the scene so it can light up some parts of the shapes, finally adding it to the scene. Now everything works as it should. All three shapes are visible. You should check the documentation for other types of lights like ambient, directional, hemisphere, or spot. Experiment placing them on our scene to see how they affect it. So this is pretty much the final result. This is what we have here. Now this look a little boring, though in a game something is usually happening. We might see animations and such, so let's try breathing a little life into the shapes and by animating them. So now let's do the animation, and this is going to be very quick. So animation, we already use rotation to adjust the position of the cube. We can also scale the shapes and change their positions. To show animation, we need to make changes to these values inside the render loop so they update on each frame. Rotation, rotating is straightforward. You add a value to a given direction of the rotation on each frame. Add this line of code right after the request animation frame invocation inside the render function. Inside okay, so inside the render function, so we're gonna go inside of the render function, and pretty much we are gonna have cube that rotation that y. So we're gonna have cube that rotation that we're gonna use the y-axis, and we're gonna set it to, okay, so we're gonna use the addition assignment operator, and we're gonna set it to 0.01 and then with a semicolon. And okay, as you can see, it's working, it's moving. And again, this is the same as saying that the cube that rotation that y is gonna be equal to that the cube that rotation that y plus 0.01. okay, this rotates the cube on every frame by a tiny bit so animation looks smooth. Yeah, you can play around. Instead of 0.01, let's just 0.1. so let's see what happens. And this is what's happened. So it's moving really fast. So yeah, you can play around with these values. Let's keep it to 0.01, and now we're gonna use the same, well, we're gonna use the scaling. We can also scale an object applying a constant value. We could make it grow or shrink just once. Let's make things more interesting. First, we implement a helper variable called t for counting elapsed time, added right before the render function. So just before the render function, so it's gonna be here. We're gonna have this let declaration named t, and we're gonna set it to 0. So we're gonna initialize it to 0. That's fine. Now let's increase the value by a given constant value on each frame of the animation at the following lines, just below the request animation frame invocation. Okay, at the following lines, just below the request animation frame invocation. Okay, request animation frame invocation. Let me see. So it should be below. Okay, let me see. At the following lines, just below the request. Okay, so let's go here, and okay, so we are gonna have this let declaration, and we're gonna use the assignment operator, and we're gonna set it to 0.012. okay, so semicolon at the end. Okay, nothing is changing. So we have the t assignment operator set into 0.01, and now we're gonna use the torus that is scaled that y, and we're gonna set it to something. So we're gonna set it to the math that apps. So it's gonna be math that apps, like that, and then we're gonna pass in math, and it's gonna be that same. We're gonna open parentheses, and we're gonna have the semicolon at the end, and let's see what happens. So as you can see, this torus is rotating around the y-axis, or pretty much from up to down. Okay, so we have the torus that is scaled that y. We're using the math that apps, and then math that sine t. Okay, that's fine. What else do we have here? So finally we're gonna use we use math that sine, ending up with quite an interesting result. This scales the torus, repeating the process as sen is a periodic function. We are wrapping the scale value in math that apps to pass the absolute values greater or equal to 0 as the scene is between -1 and 1, negative values might render out towards an unexpected way. In this case, it looks black half the time. Now onto movement. So moving, aside from rotation and scaling, we can additionally move objects around the scene at the following again just below our request animation frame invocation. So pretty much we're gonna hold pretty much right here, and we're gonna have in this dodecahedron, and let me see, we're gonna have that position that y, and we are gonna set it to 7 like this. And well, nothing is happening yet, but we're gonna have the dodecahedron, that position, that y, and we're gonna set it to -7. So -7, that is being multiplied by the math that the sign, and inside of the sign we're gonna have this, the multiplication of the variable, or the let declaration t, that is a variable, with 2. With 2 we can save it. Okay, so we did this mathematical equation, and this is the result. The dodecahedron is moving up and down like it was pretty much like a soccer ball, just bumping or just jumping back and forth. The cube is moving around the axis, around the horizontal axis. The torus is moving around the y-axis, and the dodecahedron is pretty much just bumping back and forth, so, or jumping. This will move the dodecahedron up and down by applying the sign value to the y-axis on each frame, and a little adjustment to make it look cooler. Try changing these values to see how it affects the animation. So the conclusion, here's the final code, and you can check it out in the GitHub repository that we have here on this website. So you can also check out, as you can see here. And yeah, this is pretty much all that we have for the building a basic demo with Three.js software.